Hey guys, welcome back to the course. This lecture is dedicated towards another important Python library called NAPALM. NAPALM stands for Network Automation and Programmability Abstraction Layer with Multi-Vendor Support. I know it's a mouthful, and that's why it is commonly referred by its acronym NAPALM instead of the whole spiel I made earlier. Like NetMiko and Paramiko, NAPALM is also a Python library that implements a set of functions in order to interact with different network devices using a unified API. The keyword here is unified API. It means that the same functions can be run across network devices running different operating systems without making any changes to the syntax. It also shares a lot of similarities with NetMiko and Paramiko in terms of its feature set. It allows SSH based connectivity, but it is not tied to a specific vendor, and it supports multiple authentication methods, including password and key based authentication. The execution of the code is going to follow a certain process, which starts with importing a class called the getNetworkDriver. In order to use that class, we need to create its object, and we can create multiple objects pertaining to different operating systems. That object is then used to initiate the connection and issue commands. Let's now review it with a practical example. As we explained earlier, we start off by importing the getNetworkDriver class from the NAPALM library. Then we create an instance of that class using iOS driver because the network device we are using for this demo is a Cisco CSR router. If we had a device from Juniper or Arista, then we could have used EOS or JuneOS here. This driver instance is then used to connect to the network device using standard parameters like IP, login ID, and password as arguments. We then open a connection to the device, followed by running a pre-built function called getInterfaces_IP and storing its output in a variable called getIP. This pre-built function is one of many such functions that are provided as a part of the NAPALM library. We then print the output on the console and close the connection to the router. One interesting thing to note is that the output of this function is in the dictionary format. Now let's run this code and see what we get as a result. As you can see, we have a dictionary with multiple nested key value pairs. The first key is gigabit Ethernet 1, and instead of having a string or number as its values, it has another dictionary as its value. This value dictionary in turn contains another key called IPv4, which further has a third dictionary as its value. This is a classic case of nested dictionaries where keys have their own dictionaries instead of standalone values. We already have a lecture dedicated to dictionaries in this course. I would highly recommend you to watch that to get a better understanding of how key value pairs are organized in Python dictionaries. Now, I'm sure some of you may have already noticed a bit of similarity between how the connection is established with NAPALM and regular file operations in Python. If you need clarity on Python file operations, then you can check out its dedicated video in this course. In this example, we first opened a connection, then issued some commands, and finally closed the connection. This is akin to opening a file, then reading its contents, and finally closing it. And just like regular files, we can skip this explicit closure step by using the with keyword. This with keyword automatically closes the connection to the network device once the given action has completed. Let's run the code again and see what happens. As you can see, it resulted in the same output as before, and we didn't even have to explicitly close the connection with the device. I hope you now have a much better clarity on how NAPALM can be used alongside Paramiko and NetMiko to execute commands on remote network devices. So with that, I thank you for joining me this journey, and I hope you find the rest of the course useful as well.